Yeah, I'm Dr. Pete Irvine. I'm the editorial director and co-founder of SRM360.org, a website that supports an informed discussion of solar geoengineering. And I'm a research assistant professor at the University of Chicago. I've been working on this topic, these ideas to cool the planet down for over 15 years, thinking about how they would affect the climate, how they'd change it, but also about the broader implications they could have if they were ever developed and deployed.
How did your I don't know, your personal values and interests converge with the work that you're doing? Did that lead you into the subject that you cover?
Yeah, I came out of a physics degree, and I wanted to do something that applied physics, but a positive thing. A lot of the jobs that applied physics seem to be making atom bombs and missiles and finding oil, and I didn't want to do that, but I wanted to do something that applied my understanding. Also a big fan of sci-fi, and I like philosophy too. And so coming across these ideas, solar geoengineering, that we could change the climate, was really appealing because it seemed like something that might potentially help a lot, but also raised a whole lot of big issues and questions. So that it's just a really interesting problem, and one that I can talk to people about. I did a lot of very abstract quantum mechanics initially, which no one's interested in. And so this was something that everyday people could get to grips with, and something that we might use one day.
Where do you stand personally in the debate around caution versus we're running out of time?
I think a sensible answer is these ideas raise some risks, but climate change.
That's the one question where I need you to start it as a statement in a way because my voice won't be there.
Yeah. So you can try it again then.
Yeah, yeah, sure. Could you just share your thoughts on risk versus we're running out of time?
So we're running out of time in the sense that the climate is warming and will continue to warm until we eliminate CO2 emissions. These ideas, these solar geoengineering ideas, offer the potential to lower global temperatures and limit the impacts of climate change. As such, I think the sensible thing to do, the cautious thing to do, is to explore them and study them to understand whether they could reduce risks or whether they pose greater risks. Yeah, I don't think we've got time to wait around to hope climate change gets solved. I think we need to explore all our options, whether we're not ready to deploy these things today, but 5, 10, 20 years time, we want to know more about these things before we make those kind of decisions.
How does the work that you're doing, if you could just describe that, the work that you're doing, um, who do you present your work to, and what kind of feedback do you get?
Well, most of the people who spend most of the time working on this are scientists and other researchers. So we write papers for each other, we explain the topic to each other. But there's an increasing attention to this. Blah, 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 blah. Let me try that again. I suppose most of the people working on this topic are researchers. We write papers, we read each other's papers. But there is increasing societal interest in this topic, which is why I founded SRM360.org, a website where I try to summarize, or we try to summarize and synthesize what we know about these ideas so that people outside of the academic community can get to grips with the choices they present.
Can you give any examples of maybe something that's actually on your website that illustrates how taking data and information leads you to, I don't know, conclusions about what we need to do or what's happening?
Well, I think we've got an illustration on our website of a very old and simple graphic in this field. There's this. Let me try again. I think one of the things we've got on our website that I think is really important is this what's called the napkin diagram in this field. One professor drew on a napkin the climate problem, and it shows how if we don't cut emissions, the planet keeps warming. If we cut emissions, the planet stops warming, but then doesn't cool down. It stays hot for centuries. And if you suck CO2 out of the air, which is now part of the plan for dealing with climate change, temperatures fall, but only very slowly over centuries. And in that context, ideas to limit warming by reflecting sunlight could come in. They could limit the warming, keep it to some level while these other policies work. Not very complicated data, but I hope it kind of puts into context the climate problem we're in and the choices we have and the limits of the conventional policies that we have for dealing with climate change.
What are some of the challenges that you face in the research that you do? Or in terms of communicating that research, maybe the results?
This is a controversial idea, and I think and it raises a whole host of concerns that go beyond the science. And I think those concerns, that controversy is coloring how scientists are assessing this and synthesizing what we know about it. In my view, I think we need to do two things. We need to do two things at the same time. One is have a neutral, objective assessment of the science, which suggests that these ideas could lower temperatures and possibly reduce many of the risks of climate change. But on the other hand, we also need to bear in mind that they come with a whole bunch of socio-political risks. And we've got to take those seriously, but we shouldn't let those color our assessment of the science. I think that's one of the challenges the field, more broadly, the climate community has when dealing with this topic.
Maybe a sound bite on thoughts of, obviously it's about the science, but it seems that science is maybe 20% of the heavy lift. The rest really is engagement and convincing people that we need to do what we've realized we need to do through science.
Yeah, I mean, I think the core science of climate change has been settled for a long time. We know CO2 is warming the planet. The hard part is cutting CO2. This is costly, it's time consuming, it's in everything or most things that we do emit CO2. Huge amount of work to transform the economy. So often the science is just a starting point for a much deeper, more difficult political discussion and work. I think the same is true for these solar geoengineering ideas. We're learning, there's still lots to learn about them, there's still risks to better understand, but a lot of the challenge will be working out what we want to do with this, whether we can cooperate, finding ways to decide together. It's going to be very challenging. The science is just sort of a necessary but insufficient condition for getting to sensible decisions on this topic.
Personally, where do you stand in terms of your thoughts about the future, in terms of are you positive about it, or optimistic, negative?
I think I'm an optimist by nature, but I try to be realist in my science, try to weigh up the risks carefully. I mean, climate change poses very grave risks. They're not going to doom us, but they're going to doom some of us. And so I think, given the severity of that crisis, we really need to take all options very seriously. But I think my personal views on whether these things are a good idea or not shouldn't matter. I think I see my role in this field as someone who understands some of the issues, understands the science, and I try to do my best to explain that to others so that they can make up their minds about what they think we should do with this topic. I see myself as a guide to this issue rather than a gatekeeper or someone who's going to tell you what the right answer is.
That's great. Excellent. Okay,
cool.
Thanks.
No worries.